So in the last video, we discussed in detail my interview with Alex and Rose, the two students from Dr. Schroeder's integrated science class. Now I want to reflect more on what I learned from their understandings or misunderstandings when it came to forces, and really talk about why there are certain challenges preventing them from making those connections to the elevator scenario that I had proposed to them. So after the interview, I looked back through the students' answers, and I decided the biggest issue that they struggle with most is having a conceptual a conceptual understanding of forces of the material that we were talking about. I think they rely too much on what they write in class and refer to it so much that they don't take the time to critically think about the ramifications of what they're learning in class and how to apply it in a real-world situation. Now, I know that both Alex and Rose are freshmen, and this is the first time they've really been subjected to this kind of material, but even after the interview, it still seemed like they didn't know how to make that connection between Newton's laws of motions and what was going on in the elevator. For example, I went over each of Newton's laws with them. I wanted them to tell me what they were, and they got it right. Inertia was the first one. Every object in motion or at rest is going to stay that way unless something else acts on it. The second one was force equals mass times acceleration, and the third is for every action there's an equal and opposite reaction. But then when we moved to drawing free body diagrams, they didn't know they had to draw that normal force that was pointing in the direction opposite of gravity. And that tells me that they can answer a question such as, what is Newton's third law? But when you ask them to apply Newton's third law, drawing all the necessary forces of an object that's just sitting on the ground, they don't know how to make that kind of connection. Even by the end of the interview, I still feel like they didn't really understand what that normal force means. With my interview specifically, I wanted them to come to the understanding that that sensation you feel of feeling heavier and lighter as the elevator is moving up or down is that normal force. You know, it is that experience in your apparent change of weight. But they still didn't really make that kind of connection. Eventually they got to the point where they could draw it, and they can tell me, yeah, if you have an arrow pointing down, there's got to be an arrow pointing up. But they still don't know what that up arrow really means, because we don't really give the normal force a specific name. We don't really have a name for that kind of phenomenon. So then I started asking myself, why is it that it's so difficult for them to think a little more outside of the box? Why is it difficult for them to take notes on Newton's laws and not really think of them when we're talking about objects that are moving or objects that may be in rest? And I think the first thing that came to my mind was kind of how integrated science classes are structured. Integrated science classes, I think they really serve to be a survey course for these students. You know, they're required to take them before subject-specific classes, so it gives them an idea of so many different types of subjects in science that they could learn more about in the future. In Dr. Schroeder's class, they've gone, the end of the year was predominantly physics, but at the beginning it was earth science, biology, and chemistry. So I think it's offered to younger students because of that. You know, you want to get them when they're really young so that they have a better idea of if there's a specific science they would like to learn more about, then they'll take that class later on. But because they're also a lot younger than other students that are in advanced courses, and because, you know, integrated science classes need to spend less time on that material, like on physics material, as opposed to an actual physics class would, I think they're more concerned about students knowing how to apply that conceptual understanding more so than being able to explain it. In my experience at Henry Clay, a lot of the exams or assessments for integrated science classes, they had questions that focus more on, you know, using equations and just simple plugging in variables to those equations, as opposed to advanced physics, where they really need to take some time and think a little more creatively about what they really represent and how to kind of manipulate different equations. And I have an example here of problems that I've seen in both integrated science and physics classes. On the left, this would be a very standard problem given to an integrated science student, where they're given just the quantities that they need to plug into an equation and solve for the missing variable. They give you f, they give you a, and then they want you to solve for m. All you gotta do is just plug them in and divide it out, and then you have the answer. On the right side, this is something more of the speed of an advanced physics class, maybe, where it's, first off, it's a word problem. It's not just numbers, so a student actually has to read it and interpret the information given to them. And it takes multiple steps. It's not just solving one equation, it's solving two equations, and then you have to find the difference between both of these two forces. And again, I think that because we don't really focus on problems such as the one on the right for students in integrated science classes, they're not really challenged enough to absorb any kind of material and let it sink in so that they can recall on it in any other circumstances other than just, when they're sitting at their desk given a test. So the more I get to think about this, I'm starting to wonder if the biggest issue is whether or not students understand the material that they're working on in class, but if they can understand what it is we as an instructor are asking them to tell us. Maybe maybe my communication skills during the interview weren't really there, so they didn't really understand what it was that I wanted them to tell me. I purposefully phrased my opening question to be kind of a difficult one. Verbatim, my question was, use Newton's laws of motion to explain why you feel an apparent change in weight as an elevator moves up or down. And initially I thought that would be a good question because I didn't want it to just be a point-blank answer. I wanted students to think about that. I really wanted them to consider everything that they've learned in the classroom and apply it to that scenario. But without any guidance beforehand, maybe they just didn't know where to start. So the issue, I think, is knowing when to use probing questions to promote critical thinking, or just clarifying questions over and over again until they start making those connections on their own. Maybe I should have started out the interview with something a lot simpler, like, just tell me what Newton's first law of motion is. And they both knew that, so I could have just started the interview with them feeling more comfortable about knowing the material, so they'd be a little more confident in their answers. We want students to make predictions. We want them to make educated guesses. And if they start this interview, or if they start any kind of learning experience with the right answers, knowing that they've given the right answer, they take more chances in making guesses. And we want students to do that. So if I wanted to have a conversation with a student about what are the relevant forces that are acting on you as you're moving up and down an elevator, I can only get to that point if I can first have a discussion with them about what are the relevant forces acting on you as you're standing perfectly still. And we can only have that kind of conversation if we've really mastered forces and what they are. And the only way you can do that is if you have an understanding of vector quantities. And you only get to that point by building on other material. So throughout this interview, it's really shown me that this is how we should structure the lessons that we give for this type of material, that you only move forward by truly mastering all the relevant previous content that builds on itself. If I could have just started out the interview by asking only tell me Newton's laws of motion. That would have been a good start. So then I could have helped shown them. Now think about Newton's third law of motion. If there's an equal and opposite reaction, if I'm standing perfectly still knowing that there's gravity pushing me down, why aren't I falling through the ground? And then that might be easier for them to imagine in their heads, and they can give me an answer like, it's because the ground is pushing you back up. That would be a really important step for them before it comes to you're standing still, but in an elevator that's still moving up or down, right? That's still a really good foundation to have. So I think the biggest problem that I had was I tried asking a very difficult question from the very beginning of the interview, hoping that that would spur some critical thinking for both of these students, when really I should be asking increasingly difficult questions, always being the facilitator for their critical thinking, always asking a very simple question and then allowing them to tell me the connection between two simpler ideas. And we continue building from there until we would have gotten to the end point, which was you experience that change in your apparent weight. Obviously your weight doesn't change, but it feels like you weigh differently moving up than you do weighing down.